Hey guys, I'm Jade. Today is my LeetCode review vlog on the 226th problem, Invert Binary Tree. We are given the root of a binary tree. We have to invert tree and return its root. Let's example 1 here to understand it easily. All we're going to do is to swap the left and the right children of every node in the binary tree. For example, we have to move the node 2 to the right and to move the node 7 to the left, and so on for every node inside this binary tree. Then, let's get started with our intuition to solve the problem. And there are two approaches to solve it. And the first is called recursive depth first search. And the second is called iterative breadth first search. And we'll start it by the recursive approach first. All we're going to do is to recursively invert the left and right subtrees of every node. Then let's get started with the code and annotations to solve the problem. The very first thing, we have to handle edge cases. If root equals null, we just return null. Second, we have to recursively invert the left tree and left subtree and right subtree by reusing the invert tree method. And the code is tree node left equals invert tree method. We have to reuse this method to do a recursion approach. Root dot left and tree node right equals invert tree of root dot right. Next, we have to swap the left and right children. Root dot left equals right and root dot right equals left. Then we just return the current node as the new root of the inverted subtree. Return root. And that's all of code for the first approach, which seems very simple. Then let's analyze the time and space complexity. So the time complexity, it is big O of n. And n stands for the number of nodes in the binary tree, as we visit every node for only one time. And the space complexity, it is big O of h. And h stands for the height of the tree. And this is because the space, it is used for the recursion stack. And in the worst case, the height of the tree can be n if the tree is an unbalanced binary tree. But in the base case, if the tree is a balanced tree, it could be big O of log of n. So h is between n to log of n. And this is the first approach. We can also implement this method by the second approach. And it's called the iterative breadth first search. All we're going to do is to use a queue to perform a level order traversal. And inside it, then we can invert nodes level by level. Then let's get started with our code and intuition of the second solution. First, we also have to handle the edge cases. The edge case. If root equals null, we just return null. Next, we have to create an empty queue to preparing for the level order traversal in the following state. Queue of tree node. Let's call it queue equals new queue, a new linked list. Next, we'll add the root node to the queue.offer the root node. Next, we'll have to create a while loop to process all the nodes while the queue is not empty. While not single queue dot is empty. Oops. If the queue is not empty, we'll keep this for loop. And inside the while loop, first, we have to remove the front node from the queue. The code is tree node of current equals queue.poll. Next, we have to swap the left and child children of the current node. Tree node of 10 equals current.left and current.left equals current.right and current.right equals 10. Next, we have to add the left and right children to the queue if they are not null. If current.left is not equal to null, then we have to add it to the queue.offer of current.left, and it's very similar for the current.right. Current.right is not equal to null, then we'll put it into the queue offer current.right. Then, out of the while loop, we just return the root of the inverted tree. Return root. And let's analyze the time and space complexity for the second approach. The time complexity, it is also big O of n, and n is the number of nodes in a binary tree. And we also just visit every node for only one time. But the space complexity is a bit of different, which is big O of n. This is because we create an extra queue to store all the temp nodes. And in the worst case, the queue could store all the nodes at the last level of the tree, which is big O of n, or which could store a half of the nodes at the last level of the tree. So the time complexity of the second approach, it is big O of n. Then, let's submit the code to check for the first approach first. Oops, a linked list. I typed it wrong. I will correct it. Then, let's submit it again to check for the correctness of the first approach. Yes, our first approach got accepted. Then, let's submit the second approach to check it and rename the first approach. Yes, our second approach also got accepted. And this is the end of my LeetCode review vlog on the Invert Binary Tree problem. And I highly recommend you guys to visit my online GitHub page here. You can see all the nodes for top 150 LeetCode problems. And for each problem, you can see very detailed problem description, intuition, Java code with annotations, and a final time and space complexity analysis. You can also visit my GitHub repository here, which contains all the nodes and codes to build this online GitHub page. And thank you guys for watching. And I'll put those two links on my YouTube description below. And thank you guys for watching again, and I'll see you next time. Bye bye.